Hello everyone, this is my last part, because actually I'm getting bored with it. Basically, well, no, not bored. I just don't have a clue what I'm doing really. But anyways, right, my first curve tracer is, right, I did an instructable, so this is how my first curve tracer went. This is how my part 2 is looking. Looks totally different, although there's nothing connected to this at the moment. But what I've said in there is that there's types of curve tracers, DC curve tracers that use a ramp or a sawtooth voltage sweep to test static current versus volt characteristics. This is okay for diodes and transistors, basically anything with a silicon junction, and that's what it looked like. With so there were two sets of probes, and you know, if we stuck one probe on, I get a curve trace like that. And we get something that we can compare with another one. If we put something else under test, we can compare the two, so we get two things. So I mean, like for the thing I've got under test is what have I done with that? Right, so yeah, I've got two of my boards that I use, so we can compare these two, and it works fine, and it found a fault for me first time round. But what I thought was the trouble with this is I'm using an ESP8266. It runs at 3.3 volts, and I can only do DC. I can't to use AC. You need a lot of circuitry in between to sort of flip things around and get DC results, and then you look at the DC results, and then you do a graph from that. So what I thought was to emulate well, it's a silly thought, but you know, it's a thought, to emulate a negative voltage is swap the probes around. So if we swap the probes around, then the current is running in the opposite direction. So basically, it emulates the reading in it, so that the negative is connected to the positive, and positive connected to the negative, sort of thing. So I thought I'd get two switches. I've got these two switches here, and believe it or not, these little tiny little things are double pole, double throw switches. These are actually these actually act like physicals. One moment. Someone knocked on the door. I forgot where I was now. Oh yes, flipping the things. So what them switches are like is basically is something like where am I getting? It's basically a switch like this. So it's double pole, double throw. So it's like flicking one of these switches. Get that in focus. There we go. It's like flicking one of these switches. So basically, what we can, well, I'll show you the diagram. Let's get that in focus again. There we go. Yeah, so that's what one of these is here. So we can flick the switch electronically from my microcontroller. Can flick this switch back and forth, and I've got one for each probe. Let's have a look at the circuit. I've got it somewhere. Yeah, here we go. So yeah, that's each one of these little things here is one of these here. This here. There, that is one of them, and this is the other one. And what we can do is the actual switch is controlled from my microcontroller. I've got them both connected together. They're all on one pin here, and so when this goes high, it switches one way, and when it goes low, it switches the other way. So what it actually is doing is switching my probe. This probe will be my probe 1, and this will be my ground. And what it does, it swaps them around. And I thought, yeah, that we can emulate current flowing the other way that way. And so when we're taking readings with the current flowing in the opposite direction. But I think there is some sort of, I don't think these are totally independent of the actual power supply. They should be, but I don't know. It doesn't seem to act the same way. It might be something I've done in the code. I don't know. But anyways, what happens is, what I wanted to do was do a sawtooth waveform, emulate a sawtooth waveform. Yeah, emulate a sawtooth waveform, but no, sorry, not sawtooth, a triangular waveform. So if you imagine this screen as an oscilloscope, let's get something to draw with. Not that one, smart audio. Where are we? Oh, is it this one? Oh, here we go. Yeah, I forgot. There we go. So if we get that to draw. So if you imagine this here as an oscilloscope, and we were sending it in a voltage, what this one did was as the current increased, what I did was it was basically a ramp up and then a ramp down, and then a ramp up and drop down. So this used an actual like a sawtooth waveform. I think I showed it in the video. And so I got this sort of waveform. But what I was thinking was, right, well, if I could make a triangular waveform instead of that, what clears it? Oh, there, yeah. Instead of doing that, what if I did this? I ramped it up and then I ramped it down instead. And then what I could do is when I flip my probe, do another one, I could flip my probes, which would then emulate another one going down like this. So that's what I've done. So let's just bin that. So what we can do, how do I get rid of that? No. Oh, that. Yeah. So what I can do is that's what I did. Yeah. So if we look at this, what this is doing is, first of all, I flip my probes and then I ramp up. In real life is from the microcontroller, because I can only do DC positive. What I'm doing here is I am doing a ramp up, then a ramp down, then a ramp up, then a ramp down, and so on like this. So that's what I'm doing with my DC current at the moment. But what I do is when I'm doing this first bit, I invert my probes, which should basically emulating this. It should actually flip that. So instead of reading a positive, it should be reading a negative, I think. Well, that was my theory, and then what I'd do, I would then flip it again, and so we would end up with basically a triangular wave like this sort of thing, because this is reading the probes in reverse order. So what happens here is when the current is flowing in the opposite direction, basically the current is flowing this way, and when it's that way I flip the probes and the current is flowing that way, and so I should end up with a triangular waveform. And as you can see, we currently have that triangular waveform, sort of. It's got flats here, and the reason for these flats here is because it goes through a transistor, and as we know, when you go through a silicon junction, you lose maybe what is it, 0.6 volts. So you've got to get greater than 0.6 volts before it starts registering. I'm not quite sure about the top bit though. I don't know why it clips at the top. That's probably my fault again, but I just can't be asked to find out why I'm doing that. So yeah, I could show you this with the oscilloscope. So if I bring this my thing up, so we can see where I'm probing. Let's just bring that forward a bit. There we go. Yeah. So this is my signal out. So this is where I'm coming out. Well, it's pulse width modulation. Then it goes through these capacitor and resistor to give a to filter it. So we get an actual smooth voltage. So let me just bring up my oscilloscope. Is it that one? Yeah, there we go. So can I put that over there? Yes. So yeah, let's do some probing. If I don't tangle myself up in my microphone wire. Yeah. Here's my probe. I've just stuck a. I can't get that in shot. I've just stuck a fly lead on the end of this probe, so I can plug it in. So if we plug it in to well, it comes out of the microcontroller through this yellow wire over to here, to this transistor. This is what I was on about with the flats, because I've got this transistor. It's a silicon junction, so there is that 0.6 volts threshold it has to go above before it actually switches on. I suppose I could buy a more expensive or use a more expensive transistor if I've got one somewhere, but you know me, I can't be asked. It's only an experiment, is this? And so yeah, so if I plug my probe onto this yellow wire, which is what's coming from my microcontroller, plug that in there. There we go. We can see that. Hey, why did it go off then? I don't know. Right, yeah, so we can see that I'm ramping up, ramping down, ramping up, ramping down, but it's all positive. So to get a negative, what I do is I flip my probes around every other one of those. Now you can see that this signal is okay before the transistor, and I can show you the flats after the transistor. So if I move this probe after the transistor, which is on this, where this resistor goes in, there you can see the flats. So this is after the transistor, so you can see I've got some flats at the bottom here. That is because of the silicon junction. So as this is just a prototype and just made with bits I've got hanging around, I live with it. I know the reason for it being there. That's why it's there. So but if you can just imagine every other one of these, I switch my probes around. So if if we look at my two probes, these two, this one here becomes this one, and then this one becomes this one. So what I'm doing is I'm switching them around electronically like that. So basically whatever they're connected to, the current flows in the opposite direction, which emulates a triangle wave going positive to negative in the negative direction. Well, I hope I explained all that. I don't know if I did. Anyways, let's do some measuring and see what happens. So I'll just move that back a touch, put some room for my well, I've just lost all my light. Let's go back a bit. How's about that? Yeah. There we go. So I'm using these two boards that I made. I know one of them it's got something wrong with it somewhere, and one of them hasn't. One of them works, one doesn't. So what we can do is we can wire them up like this. So what we can do is, if I put this onto the negative, like that, and the other one's on the negative, can I get that a bit further? There we go. Let me focus. How many bollocks? There we go, that's more like it. Yeah, so I've put them onto my negative pins, and then what we can do, just like before, is compare, but it will be slightly different this time. So if I put that on... Oh, I haven't got my thing. We can't see the curve tracer. Oh, let's get rid of that. Put that over there. And move these across here a touch. How's that? Yeah. So yeah, so we can go around all these pins, and so with this probe I'll go around all one of these, and then with this probe I'll go around with them, and we'll get some sort of trace. If I can see what I'm doing and keep it on the screen. So if I go on there, what does that do? Try that one. There. Oh, well, that one goes straight to ground. So if I put the blue one on the same place, we should end up with the flat trace again. So which one am I on? That one. So that should match, and yes, it does. Let's try that one. And that one. What are we getting there? Oh, right, yeah. Oh, right, so the blue one has given us a trace, but the... have I missed with the yellow? Let's try and put the yellow on. Oh, right, so it looks like we've got a fault there, have we? Have I got that on there? Oh, hang on. Oh, no, there we go. I've got a better connection. Right, yeah, so... You can see now that the trace gives us a result in both directions. So if the probes are swapped around, we get the left and the right. So now I'm getting like a trace with the current. What the trace looks like with the current going negative and the current going positive. Yeah, so that's interesting. Let's try something over here. I know one side's PNP, one side's N. No, one side's N channel and one side's P channel, so we may get some different results here. Oh, right, so they match up. Like I say, we can do the same thing exactly as we did before. But what we can also do, there we can see that they match up. What we can also do is I can actually put these onto, at the moment I'm doing it on the common ground. I'll leave that on there, that's on the common ground. But if I plug these two together, what I can do is I can put the other probe on the VCC, and because I'm using DC, I can see how it's going in the trace is going in the negative side and the positive side. So what we can do is I can actually put let's pick that one. What's that do? That's showing sod all. What about here? What about there? Oh right, so that's giving us a right weird look. And if I put my other probe on the same place, where are we? On there. Has that got it? Yeah, we can see that there's a difference. Let's try it on there. And try that one on there. There, how's that? There. And I went, oh no, I'm not doing it wrong. I shouldn't be doing the same thing. I should be putting them on two legs. So what I should be doing is, because I've got these on the ground and the negative, what I can put these two probes is across the outputs and inputs of the pins. So what I can do is I can check that. Right. So what we do is we've got that curve for that sequence on that one, and we just check to see if we've got the same sequence on the next. But what that is doing is giving us a bit more information on how the thing's working. So what I could do is, where have I stuck this? Stick this on the other one. Right, so that one's going in that. Try it on that leg. There. That should be the same on this one here. Right, now there we go. So now you can see that one there. So I don't know if you have I got that in. I haven't got that in focus on my thing, have I? Oh yes, I have. I've got wrong glasses on. But where I'm probing on this one here, it's got some weird characteristics. There we go. There. So you can see how that looks. And this is giving us DC going in both directions on them two pins. And then what we can do is to check this one and check what this what looks like. Oh, it looks the same. I must have had it on wrong last time. Or did I have it on the other two pins? Let's try that one. Oh right, so that one's that one. And that's that one. Oh, that looks the same. Anyway, you can see what I've done. And I've just increased the sort of range of what it can actually see. You have to know what it's actually doing to understand. But basically, with any test equipment like this, all you're doing is just doing a comparison between two similar values. I'm sure there was something wrong with one of these, but I can't remember where the fault was, unless I go all the way around. But anyway, that's my last part in that. I don't think I'm going to go any further with that. I think if you need to go any further, you may as well buy a professionally made one, not a bodge up like I've done here. Well, it's not bodge up; it's an experiment. But basically I was just investigating how things work, basically, and just the way that we can actually test things. It will help me in certain instances. I'm not a repair person, I'm more of a project builder, so I know how things should be working, and I can check that they actually are doing what they're supposed to do. It's only when I fry things that I've got to find out what I fried, basically. Anyway, I hope that was of some interest. Catch you later. Oh, well, before I go, I'm running out of things to do. I don't like to recopy what other people have done, as you can see. No, I don't think anybody's done this. So, any sort of odd ideas, if anybody has something strange, it has to be simple, just a few components. I don't mind doing a bit of coding on a microcontroller, but let me know if you can think of it, because I'm having trouble thinking of something. I have thought of something else actually. So there's another project I'm going to do. It's going to be a simple thing. Well, you'll see it when I've done it. Catch you later, guys.